Okay, so this one is talking about a logistic differential equation. So if you remember, this is the form of a logistic differential, ky 1 minus y over L. And if you remember, a logistic differential equation is a function, if it's a growing function where it grows, and then it reaches a limiting capacity. And we talked about most things in nature, almost everything in nature, models a logistic because there's a limited amount of resources. And the fastest growth rate is always at 1/2 of L. Okay, so some general characteristics. So if we know this is a logistic, you first always want to make sure you have it in this form so you can figure out what those values are. So notice it's not in this form. There's a 2 there. So I'm going to factor out that 2. So I'm going to rewrite it by factoring out that 2. So if I factor out the 2, remember you're dividing, so really this becomes 1,600, right? If you multiply it back through, 2 over 1,600 goes back to the 1,800. So I want to know if you had 100 people who had the flu, what happens in the long run? Remember, this number here is that limiting capacity. What happens in the long run? So your answer choice is C. And really, for a school, that's really the population of the school. Okay, let's look at another problem. Again, you've got another logistic, but if you look at this one, this is in this form already. It's got the ky, the variable g, 1 minus y over L. So I don't need to change anything in the equation. It says g of 0 equals 1, so the initial value is 1. It really doesn't matter what that is. I want to know what's the value of g where the population grows the fastest. Population grows the fastest when the population is half of that limited capacity. That limiting capacity is 4e, so half of that would be 2e. Okay, now we've got 2 problems with Euler's method. Remember, Euler's method is a way to approximate the y value of a function using numeric points, basically. So what I'm going to be doing is I'm just basically be writing the equation of a tangent line. And it says that I want to start at the point 0, 1. So I'm going to start at the point 0, 1. And if I want to write the equation of a line, I need a point, I need a slope. So if I plug in 0, 1 here, I have 0 minus 1, so that gives me negative 1. So writing the equation of the tangent line, y minus 1 equals negative 1. Remember, your x is x minus x1. It's the change in the x value. It tells me that I want to use 1/2 for that change in the x value. So I want to use 1/2 for this. So I'm going to solve for y. So I have negative 1/2, add that 1 over. So there's my next y value. So your previous x value was 0, but we're going to increase the x by 1/2. So my new x value is 1/2. And then we just calculated our new y value, which is 1/2. So then you just repeat the process. I'm going to write the equation of the tangent line again, but I need slope again. So again, dy dx is going to be, I'm going to plug it in here, 2 times 1/2 squared minus 1/2 squared. And if you do this, you end up with 1/4. I'm going to go over here. So y minus 1/2 equals slope. And again, x minus x1 is delta x, which is always 1/2. So I have y equals 1/8 plus 1/2. And that'll get me to my next y coordinate, which is really, I'm trying to figure out what happens at x equals 1. So the next point is 1, 5/8, and this is what I want to get to. So I stop here. So your answer is D. Okay, the last one here is another Euler's method, but your data is given in a table, but we're going to do the same thing. We're going to start with the point 1, 2, and we need the slope. And from the table at 1, 2, my slope is negative 1. Notice you are increasing the x values by 1/2, so your delta x is 1/2 here. So I'm going to write the equation of the tangent line. Y minus 2 equals negative 1. Again, x minus x1 is your delta x, which is 1/2. So this is negative 1/2 plus 2, which gives me 3/2. Then you go to your next point. Your previous x value was 1. We're going up the x value by 1/2. So your next x value is 3/2. We just calculated our next y. So there's my next point. The slope at 3/2 is going to be negative 2. So write your tangent line. Y minus 3/2 equals -2. Again, delta x is your x minus x1, which is 1/2 here. So y equals -1 plus 3/2. So my next y value will be 1/2. So the next point, your x goes up by 1/2, which gets me to 2. And here's your new y value. But this is what I wanted, so my answer choice is B.